Hello everyone, welcome to ChemUp Academy, where chemistry is simplified and success is amplified. So, in today's lecture, we shall be starting with the topics that are basically related for your UPSC Geo Chemist examination. For more details about this examination, I shall be preparing a video. For now, let's come to the topic. So, we are starting with the physical chemistry, that is, the unit shall be conductance. Alright, so you may write, you may make the proper notes. After making the notes, you will have to revise those notes. And in every lecture, we shall be just taking few lines, few topics, so that the gainment of the topics is quite clear to every children or every student who is watching my video. And also the notes are shall be particularly related to your the examination, that is the UPSC Geochemist examination. So let's target with our goals and let's start saying all the best and saying wishes with all the good wishes. So we are starting with this unit, that is the unit conductance. So starting with the most basic thing that we all must have read about in our classes 12th or 10th. So let me just start with that. Whatever conductance, whenever you hear a word conductance, the first thing that comes to your mind is like something that allows electricity to pass through it. So something that is allowing electricity or the flow of electrons or the current to flow through it, to pass through it, is known as conductor. And on basis of that only we have divided the elements, or we can say we have divided the materials on that basis only, which says that we have, okay, let's take this, we have this shape, taking this one and this one. Similarly, let's take this over here. All right, and here we can take, all right. So this was our, this is from the very basic things that we are starting with. Here we have the conductance band. Say, okay, let's not take this as our conductance band. This will be our valence band and one will be our conductance band. So we can say it as CB, that is the conductance band, and here it is valence band for all of these three. Now, when we talk in terms of conductivity, we can say that this is basically the energy gap. So when the energy gap is too large, therefore it is known as insulator. When there is no energy gap or very low energy gap, that means the energy gap is quite low, it is known as conductors. And when it is overlapping, that means the valence band is overlapping with the conductance band, valence band is overlapping with the conductance band, we call it as conductors. So this is all about the basics. इतना ही basic में आता है that what are insulators, what are semiconductors, what are conductors. Obviously, UPSC shall not be asking you about this particular thing, like how will you determine conductors, semiconductors, no. And since we are targeting UPSC for the chemistry subject, therefore the UPSC demands more in conductivity. So coming on to the actual topic of ours, that is this conductance. So how will you define conductance? Whenever we come to the definition of the conductance, we can say that conductance refers to the materials, or it basically refers to the flow of current. Flow of current, or I would say, or generalize it, flow of electrons in simple terms. Since this is chapter related to your prelims, so you may mention prelims as well. Alright, so conductance is basically the flow of electrons. So we shall be discussing about conductance and certain other related terms. Coming on to the conductance, conductance तो समझ में आ गया कि conductance ठीक है, it is referring to the flow of electrons. Now, what is allowing the conductivity? Like what type of materials could be conductive? So two types we have. First is we can say that doping. Doping is nothing but you are adding extra element, extra matter, or we can say the metal to your compound so that the electric conductance could be initiated. So basically, adding something or impurity to the pure metal is called doping, and in this we add metals. Metals are generally releasing the electrons, due to which the conductivity is observed. Now we can also say that electrolyte electrolytic solutions also conduct electricity. We all are aware. And in electrolytic solution, what is the basic factor that is prevailing? The basic factor that is prevailing is nothing but the ions. So these are the basically two things that we can see or we can observe. That is conductivity आती कहाँ से, conductance हो कैसे सकता है. First of method is your doping. Another one is saying that electrolytic solutions. In doping, the metals are used which are releasing electrons, and here in electrolytic solutions we have ions. Also, ions could be your cations or ions could be your anions. So these are basically the two type of ions that could be used, that is the cations and the anions. So this is whole about your introduction. Coming on to the effect of temperature, like what if I tend to increase the temperature? Say we have conductance. Now we have a doped material. In that doped material, what I am doing is I am increasing the temperature. On increasing the temperature, my conductivity influence will be that electrons are being released and they are allowed to move freely, randomly in that particular space. Since they are moving in that particular space, therefore the space is specified. The space is specified, and it is saying that only this much amount of space is available for electrons to move around. Since the space is specified, therefore the conductance for the electron with increase in temperature, the conductance usually decreases. So question can be asked saying that how is conductance varying with the temperature for doped material? Like they won't be asking doped material, obviously they would be mentioning this word metals. So accordingly you need to say that or think about that doping was the particular thing on which we need to just think upon. Another thing is like when we increase temperature on this part, since we are increasing temperature for electrolytic solutions, that means ions would be there. More generation of ions would be there with increase in temperature, that is the dilution effect could also be observed. Therefore, here we can say that conductivity over here increases with increasing temperature. So this is the basic difference that one must know. Coming on to, okay, we can also conclude it like temperature inversely conductance, and over here it is directly with conductance. All right, coming on to the next particular thing, that is the next definition or the basic definition that we have is the basic terms. Let's study about the basic terms. Okay, so sorry, the first basic term, here you can mention basic terms. Okay, 3D shapes are also being provided to us. All right. Coming on to the basic term, the first term that we have is resistance. You would be like, बचपन से पढ़ते हुए आ रहे हैं, what is the basic thing? Resistance is basically something that is not allowing the current to flow. So something that is resisting the current, the flow of current, something that is stopping the flow of current is basically known as your resistance. So you may write it as stopping current to flow. There are definitions that are usually asked, but these are definitions that UPSC won't be asking. Obviously, we cannot predict anything since it is UPSC, and you must have seen about this year paper as well. What have happened to actual UPSC? I'm not saying this is not actual, this is also actual, but this is the other side, the other branches, the remaining branches, or the other side of UPSC, but the main UPSC actually holding for IAS, IPS positions. So the type of question paper they have revealed and the type of expectation that people were expecting this time was quite different. So on basis of that, we can just go with the flow, which says that resistance is stopping current to flow. This is one thing. So now we can represent resistance as this. This is how we can represent resistance. Now resistance is also inverse of कंडक्टिविटी. जितना ज़्यादा कंडक्टेंस होगा, जितना ज़्यादा अलाउ हो रहा होगा फ्लो ऑफ करंट को टू मूव टू पास थ्रू दैट ऑब्जेक्ट, रेजिस्टेंस उसमें का क्या हो जाएगा, इनवर्स हो जाएगा. सो दैट इज बेसिकली रिप्रेजेंटिंग द इनवर्स. In order to remove this inverse signs, or in order to remove this proportionality sign, we need to involve certain thing. We need to involve certain thing which says that रेजिस्टेंस बेसिकली आपका डिपेंड करता है L अपॉन A के ऊपर. L इज द लेंथ, A इज द एरिया. लाइक कितने एरिया में से, इन विच, फ्रॉम विच एरिया, यूनिट लेंथ की कितने एरिया में से कितना कंडक्टेंस जा रहा है, कितना रेजिस्टेंस हो पा रहा है. सो दैट इज बेसिकली योर कंडक्टेंस एंड रेजिस्टेंस. Conductance if I talk about, resistance if I talk about, they are basically inverse of each other. So like that you can understand. Another thing is that here you may write it as 1 upon C. C over here is referring to the conductance, R over here referring to the resistance, and here we have, in order to remove this proportionality sign, what we need to involve is, we need to involve a certain sort of constant, which is saying that is equals to rho L upon A, where this rho is basically representing something like resistivity, or we can say specific resistivity. When something specific resistivity is being represented, that basically refers to your rho. Specific resistivity is nothing but the resistance that is offered per unit length and meter square. Because it is area, so it is meter square. So the resistance that is being offered per unit length in the meter square, or that is the area that is being provided. Coming on to the units, if we talk in terms of unit, we can say that the SI unit for resistance, as we have studied in our lower classes, it says it's ohm. Since it is ohm, we can place the values over here. Now on placing the values, we can say that this is ohm. Over here resistivity की unit निकालनी है, length says meter and upon meter square it is saying. These two will go up, 1 meter got cancelled, and rho will be over here. Let me continue over here. Rho as it is equals to ohm into meter upon 1. So resistivity is known as ohm meter. This is your resistivity. So this is all about resistance, one must know. First of all, the formula over here specified below. Then the units, SI unit, and over here the specific resistivity, that is the resistance flowing in the length of 1 meter. Coming on to the next thing that we have, it says conductance. When we talk in terms of conductance, C would be referring, and if we talk in terms of conductance, the SI unit, इसकी क्या थी, ओम. ओम का इनवर्स होता है ओम इनवर्स, और वी कैन से साइमन इनवर्स. These could be the units. Also, when we are saying that conductivity, or it could be represented as G as well. Sometimes it would be written as G, so you can mention it as G as well. So when we talk in terms of G, we can say that G we have G we are having. Let's inverse this formula. On inversing this formula, we would be getting A upon L, and this will be 1 upon this. 1 upon rho shall be represented as kappa. This is 1 upon rho. So G could be written as A upon L into kappa. Here it is specific conductivity. Sorry. It is specific conductivity. Here it was specific resistivity. So similarly, we can calculate the units of for kappa as well. So this shall be your homework, to let me know the units of kappa on placing the units here. Here we have ohm inverse, here we have meter square, and here we have meter. So like this you can calculate the unit of kappa, and you can comment me down. This shall be your homework. Alright, so you may take a screenshot for it. Coming on to the next topic, another thing that we have over here is cell constant. Third one it will be. Third one says cell constant. बचपन में whenever you must have studied the first time electrochemistry, conductivity, conductance, ionic equilibrium and all those topics, जब आपने पढ़ा होगा तो you must have seen this diagram. Here the electrolytic solution is there. Here your electrodes are attached along with this, like this, so electrodes. So the distance between these two electrodes, the area of contact, is basically known as your cell constant. It is nothing but the length between the electrons. You can refer to length between the electrodes or area of contact in electrolyte. So this is basically cell constant, which is usually represented in terms of this. This is how we represent it. And if we talk sorry, if we talk in terms of formula, we can say that this will be your formula for cell constant. So we have studied about the three terms, that is resistivity, conductivity and cell constant. Coming on to the next term, that is the molar conductivity. Molar conductivity, or the fourth term, is molar conductivity. When we talk about the molar conductivity, मतलब volume shall remain same, but कितना amount flow हो रहा है of the current or the conductivity allowed for 1 mole. Always 1 mole. Volume कुछ भी हो सकती है. Volume may vary and moles 1. That refers to basically your molar conductivity. So sometimes people get confused ki how to take or what to take. So for this, regarding this, let me take an example. We have two solutions, solution A and another one is solution B. Solution A is saying we have 0.1 molar, solution B is saying we have 0.01 molar. What was the formula of molarity? If we think about molarity, we used to say that number of moles upon volume of solution in liters. So if we break it out, we can say that mole would be 1 upon 10. Here if we break it out, we can say that 1 upon 100. That means this is your moles, here is your volume. This is your mole and here is your volume. It means only one ion or one mole is there in 10 liters. Whereas over this side we can say that only one ion is there in 100 liters. Say only one person is traveling in a bus and say only in 10 buses, for 10 buses are available for one person, and over here 100 buses are available for one person. Therefore, the probability of roaming randomly, that is the probability of roaming randomly for a person, will be more over here as compared to here. And whenever we talk about the conductivity, we always talk about the randomness of the mobility of the ions. Therefore, ज़्यादा mobility कहाँ मिलेगी? यहाँ. Conductance कहाँ ज़्यादा होगा? यहाँ. Here the conductivity will be more and here conductivity shall be less. So this is basically how you can differentiate molarity क्या होती है, molar conductivity या फिर molar conductance, how can we determine? So that is basically the conductivity, how molar conductivity, conductance changes for solution A and for solution B. So this is the basic simplified version that you can remember for a longer period of time, that is the breaking of the moles. Here very dilute solution is there. Therefore conclusion, in conclusion we can draw something like, for conclusion we can draw something like, conclusion says that more diluted solutions are more conductive in nature. This is whole about the molar conductivity or molar conductance. And if we talk in terms of, I would say, sorry, and if we talk in terms of formula or formulation of this, we can say that the formulation could be represented as G upon N is equals to your molar conductivity. Since I am taking per volume, therefore I would taking a divide over this. G by V upon N by V is equals to your molar conductivity. Now G by V becomes your kappa and N by V becomes your concentration, and hence we have derived a formula for molar concentration as well without actually remembering the things, which says that G upon N is molar conductivity. G was your conductance per mole. Conductance per mole is your molar conductivity, and by dividing it by volume, since we are talking in terms of molarity, molarity is basically a reference to your volume and number of moles. Therefore, we are talking in terms of moles. We are talking in terms of concentration, and we have derived a simple little formula which could be used for further solving the questions that are related to your UPSC Geochemist examination. So this was all about the basic concepts and the basic terms. In the next lecture, we shall be talking about the dilution factor, the Kohlrausch Law, and the independency, and every other topic shall also be covered along with the questions. So till then, stay tuned and keep watching.
ChemUp Academy. Chemistry simplified. Success amplified.